Stop everything you're doing right now, because what I'm about to tell you will make you question everything you thought you knew about our solar system. There is a storm on Saturn that has been raging for at least 40 years, possibly much longer, and it is shaped like a perfect hexagon. Not a rough, wobbly, almost hexagon. A near-perfect geometric hexagon sitting at the top of an entire planet. And nobody fully understands why. Let that sink in for a second. Nature, on its own, on a gas giant 886 million miles from Earth, drew a six-sided shape so precise that it would make a mathematician cry. Each side of this hexagon stretches approximately 14,500 kilometers long. That means each single side of this storm is wider than the entire diameter of Earth. This isn't a small weather event. This is a structure so massive that you could fit roughly 4 Earths comfortably inside it. Here is where things get genuinely strange. Storms on Earth, hurricanes, cyclones, typhoons, they all spin in circles. Every major storm system on every planet we've ever observed moves in circular or elliptical patterns. That is what fluid dynamics predicts. That is what physics says should happen. But Saturn looked at the laws of physics and apparently decided they were just suggestions. The hexagon is a jet stream, a fast-moving band of wind that travels at speeds of approximately 320 kilometers per hour, and somehow, impossibly, it maintains those 6 rigid, almost geometrically perfect sides while doing so. Now here's the part that science educators don't always tell you. This storm was not discovered yesterday. Voyager 1 and Voyager 2 spacecraft spotted it back in 1980 and 1981. That means this hexagon has been confirmed to exist for over 4 decades. But here's the controversy that keeps scientists arguing. The hexagon was almost certainly there long before we arrived to photograph it. Some researchers believe it could be hundreds, possibly thousands of years old. There is no confirmed upper age limit. We simply do not know how long this thing has been spinning. When NASA's Cassini spacecraft entered Saturn's orbit and spent 13 years studying the planet from 2004 to 2017, it sent back the most extraordinary images of the hexagon ever captured. What Cassini revealed changed everything. At the very center of the hexagon sits a massive polar vortex, a swirling hurricane-like storm system with an eye roughly 50 times larger than a typical hurricane eye on Earth. So you have a hexagonal jet stream acting as a border wall, and inside that border lives one of the most violent storm systems in our solar system. Here is the part that breaks people's brains. Laboratory experiments on Earth have actually replicated hexagonal storm patterns. Scientists at Oxford University created a rotating cylinder of fluid with different rotation speeds at the center and outer edges. And guess what formed? Geometric polygon shapes, including hexagons. This tells us that the hexagon is likely the result of the difference in rotation speed between Saturn's polar region and surrounding atmospheric layers. The mathematics of fluid dynamics, under specific conditions, can produce geometric perfection. Nature isn't breaking the rules. Nature is just operating at a level of complexity most of us never imagined. But wait, because Cassini delivered one more twist that nobody expected. For years, the hexagon was observed as a deep blue color when viewed in certain wavelengths. But as Saturn moved into its spring and summer season in the northern hemisphere, scientists noticed something remarkable. By around 2016 and 2017, the hexagon had shifted in color from blue to a golden, yellowish hue. Researchers believe this color change was caused by the increased sunlight during Saturn's seasonal shift, which triggered chemical reactions in the upper atmosphere. This means the hexagon doesn't just exist, it responds to seasons. A storm that changes color with the seasons. On another planet, millions of miles away. Now let's talk about what we still don't know, because this is where it gets deeply humbling. We do not know with certainty what keeps the hexagon stable. Most storm systems on gas giants are chaotic and shift over time. Jupiter's Great Red Spot, another iconic planetary storm, has been shrinking for decades and has changed shape significantly. Saturn's hexagon has maintained its structure with remarkable consistency for as long as we've been watching it. Scientists have proposed that the lack of large land masses or solid surfaces on Saturn means there is nothing to disrupt the jet stream's shape. But that explanation still leaves enormous gaps. The mathematics works on paper. The visuals match laboratory models. But the full picture of why this hexagon is so impossibly stable remains an open and actively debated scientific question. What this hexagon forces us to confront is something deeply uncomfortable. We often assume that geometry, precision, and symmetry are the products of intelligence or design. We see a hexagon and think of human-made structures, architecture, engineering. But the universe is older, stranger, and more mathematically rich than our intuitions can handle. Geometry exists in nature at scales and locations we haven't even begun to fully explore. Saturn's hexagon is not magic, but it is a reminder that reality is under no obligation to be simple, predictable, or easy for human minds to accept. Cassini's mission ended in September 2017 when NASA deliberately plunged the spacecraft into Saturn's atmosphere to avoid contaminating its moons. The data it collected continues to be analyzed today. Every year, new papers are published refining our understanding of the hexagon. The science is still happening. The mystery is still alive. If you found this fascinating, follow this page right now because we cover the most mind-bending discoveries in science, space, and the natural world every single week. You won't want to miss what's coming next. Now tell me this. If a perfect hexagon can form naturally on Saturn through fluid dynamics alone, what other geometric shapes might be hiding in planetary atmospheres we haven't studied closely enough yet? Drop your answer in the comments below.